Hello friends, this video on electrochemistry part 17 is brought to you by examfear.com. No more fear from exam. Now let's understand a very critical topic called electrolytic solution. Right? Substance which furnish ions in solution and conduct electricity is called electrolytes. See, electrolyte means it has this word electricity also. So substance which furnish ions in solution plus they conduct electricity. They are called electrolytic solutions. For example, NaCl, you put in water, this becomes Na plus ions and Cl minus ions. And these ions conduct electricity, right? Other example is KCl, right? Or even HCl, even acetic acid. Acetic acid also you put in water, you get CH3CO minus NH plus. Correct? So those are called electrolytic solutions. For example, this is my NaCl here in this water. So this, if you connect this to battery, this circuit actually, you see that the bulb will glow away. Why? Because this NaCl, Na plus and Cl minus ions, these ions will conduct electricity. On the other hand, substances that do not furnish ions and do not conduct electricity are called non-electrolytes. For example, in this case, you take water and you add sugar, right? Or you add, example is, other example are benzene, carbon tetrachloride. One example is sugar. You take water and put some sugar in that, and then you create a circuit like this. Then you will see that circuit is not complete and the bulb will not glow. So in this two case, with this experiment, we can see that there is something which is connecting these two lines, right? These two rods or these two plates. And that is nothing but my ions. And here, since there is no electricity passing through this bulb, assuming the battery is in working condition, that proves that there is no bridge between these two plates. That means there is no ions here. So these kind of solution is called non-electrolyte. And this is electrolyte. Correct? So I have electrolyte and non-electrolyte. Correct? So if you go deep inside electrolytes, you will see that there are two kind of electrolytes, weak electrolyte and strong electrolyte. So substances that are completely ionized in the aqueous solution are called strong electrolytes. So they are completely ionized. For example, NaCl, NH4Cl, KCl, HCl, right, HBr. So these guys are strong electrolytes. The moment you put in water, NaCl will almost be Na plus MCl minus. Right? And substance that ionize only to certain extent, right? Only partial ionization, you can say. Maybe 5%, 2%, 10% like that, right? They are called weak electrolytes. For example, acetic acid, ammonia, ZnCl2, HgCl2. So these are called weak electrolytes. And please note, strong and weak is a relative term, right? If we talk about NaCl and CH3COH, you will see that NaCH is stronger than CH3COH. If we talk about, let's suppose, HCl and KCl, you can see that KCl is stronger than HCl. So this is a relative term actually, but broadly, weak electrolytes are those which are which are partially ionized, maybe 5 or 10%, and strong electrolytes are the one which are completely ionized. Now let's talk about the conductance. If we talk about the conductance, we know that what is conductance? Conductance is nothing but ease of flow of electric current through a body. Ease of flow of electric current through a body. And this body can either be a metal, for example in this case, or it can be a electrolyte, because we have seen that electrolyte conduct electricity. Correct? So conductance is nothing but ease of flow of electric current through a body. So if you put a metal here and you create a circuit with the battery here, you will see that the bulb glows. Same thing with the electrolyte, and assuming you're using NaCl electrolyte, so they'll have ions and they'll conduct electricity. So that is conductance. Correct. So that is conductance, and resistance is just opposite of conductance. Resistance offered to flow of current is called resistance. So ease of flow of current through a body is called conductance. Similarly, resistance offered to the flow of electric current is called resistance. And thus I can say that conductance is equal to 1 by resistance. Right? So we have conductance in metals and we have conductance in electrolytes also. So let's discuss this metallic and electrolytic conductance. So let's discuss the metallic conductance now. So if you have a metal, you create a circuit like this, the bulb will glow. So what is metallic conductance? The tendency of metal to assist the flow of electron through it, right? This is nothing but tendency of metal to assist flow of electrons through it, and that is called metallic conductance. So it depends on a lot of things. It depends on the nature and the structure of material. I'll show you how. It depends on the number of valence electron per atom. So if you see, we'll see that per atom will have a valence electron. In fact, valence electron is the one that is responsible for the conductance of electricity. It also depends on the temperature. It actually decreases with increasing temperature. Right? Why? First, let's understand how this conductance happens. So this is how the metallic conductance happens. See, we are passing a battery here. Let's suppose the red one is my negative charge and this is a positive charge. There's a potential difference. So the electron, the blue one which is moving is the electron, and the way it moves, if you see, it jumps around different valence shell. The outer one is the valence shell. So the electron flows. That's how the conductance work in metallic substance, right? Now if you increase the temperature, what happens is the flow of electrons through these atoms is difficult, right? Because the moment you increase the temperature, these atoms which are now just rotating or rotating here, they also start haphazard movement, right? So with this, the metallic conductance decrease. Why? Because this, I'll show you one graph where you can see actually one animation, because these copper atoms or any atom, they also start moving. Since they also start moving, the electrons, for electrons to move from left to right becomes difficult, right? So when a potential difference is applied across the metal, electrons flow along this direction of the electric field, and thus we can say the current is carried. So more details on the effect of temperature we'll discuss in the next slide actually. So let's see. Assume that at room temperature the atoms are moving in this speed. On heating, obviously we have seen that the entropy increase in the atoms inside the metal. I'm assuming that both are copper metal now. Both are copper. Now what happens is, if I have electron, I have to pass from left to right. Right? If I have electron, I have to pass from left to right. Tell me which scenario is easy. Obviously first scenario, because if you see, the electrons are moving at a very slow pace, right? So for one electron to move from left to right, it is pretty easy. But in this case, for an electron, on heating, the electron becomes haphazard, right? The entropy increase and they keep moving here and there. So for an electron to move from left to right is difficult, or right to left, in directions, difficult. When if you consider yourself as electron, and then if you see, for you to cross this, it is pretty easy, right? Because this are in a slow motion. But for you to cross this will be a little difficult, because then high motion, right? You may collide. So with that, it is pretty obvious that on heating, the conductance of a metallic substance decrease. Correct? Because when you increase the temperature, right, these atoms move around. Correct? And these restrict the flow of electron. And let me discuss some formulas here. So resistance is directly proportional to L by A. What is L? L is the length of the rod. and A is the cross section of the area. For example, in this case, if I am passing current from here to here, this is my length and this is my area, right? For example, I have a wire like this and I'm passing current from electron from here to here, then this is my length and this is my area. So it is directly proportional to resistance, because the more is the length, the more distance the electron has to travel, right? So it is, the resistance will increase, and the more is the area, the easier electron can travel, right? So it is directly proportional to length and inversely proportional to area. I'm talking about the resistance, because resistance is nothing but resistance to the flow of electron. So increase the area of this metal, this area, the electrons can easily travel. But you increase the length, the electron has to travel more. The more it has to travel, the more resistance it will offer. So it is directly proportional to length. You increase the area, it eases the transfer of electron. So it is inversely proportional to area. So overall, resistance is proportional to L by A. And if you want to equate this, you have to say R is equal to rho L by A. Right? So this rho is what? Rho is called resistivity. Correct? It is also called specific resistance. And SI unit of this will be ohm meter. Why? Because this resistance is in ohm and this L by A will be in per meter. Correct? So if you see, this is nothing but RA by L, right? This is in ohm. Area will be, let's suppose, meter, or L will be in, area will be meter square, length will be meter. This meter square and meter is cancel, you get ohm meter. If you put area in centimeter square and length in centimeter, you get ohm centimeter. So ohm centimeter, or sometimes ohm, ohm centimeter or ohm meter is used, but SI unit is ohm meter. Correct? And resistance is in ohms. This you have studied in physics. And SI unit of ohm is nothing but kg meter square. This is the SI unit of. Correct? Now if we talk about the conductance, we have talked about the resistance now. If we talk about the conductance, as I have told, conductance is nothing but 1 by resistance. Correct? So conductivity will be what? 1 by resistivity. So please note, conductivity is nothing but 1 by resistivity. So conductance 1 by resistance, conductivity 1 by resistivity. So conductivity or specific conductance you call by K. K is kappa, right? So I can say kappa is 1 by rho. Kappa is conductivity, rho is resistivity. Kappa conductivity, rho resistivity. Conductance is 1 by resistance, conductivity is 1 by resistivity. Correct? And conductance is G. This is G. Resistance is R. So G is equal to 1 by R. Correct? Conductivity is K. Resistivity is this guy, rho. Resistivity rho, conductivity K. Hope you remember, G is conductance, R is resistance. R is resistance, you already know. So G is 1 by R and K is conductivity, R is resistivity. You must have learned this in chemistry class. Sorry, physics class. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.